Hello everyone, this is Muhammed Mehraj Hossin 22408003, Department of CSE, Kumilla University. Today I'm going to present on Natural Language Processing or NLP. As we know, humans communicate through language and computers fundamentally work with numbers and mathematical representations. NLP acts as a bridge between these two worlds. In short, NLP is a branch of artificial intelligence that enables computers to process, understand, interpret, and generate human language. So, whenever we communicate with chatbots, generate a summary of a document, or we translate a sentence, we are actually using NLP. The NLP systems has gone through a rapid evolution throughout the decades. In the 1950s, the early research focused on machine translation and ideas like Turing test. In 1960s and 70s, rule-based NLP approaches became popular, where human manually created linguistic rules. And in 1980s and 90s, statistical NLP became important. In 2010s, deep learning and neural NLP took place, and then in 2017 came the transformer architecture that became the main factor behind many modern NLP systems. And in 2020s, we saw the rapid growth of large language models or LLMs. Now let's look at some major applications of NLP. The first one is machine translation. It converts text from one language to another. For example, I love Bangladesh is a language, is a sentence written in English. This can be translated to Bengali as Ami Bangladesh ke bhalobashi. The next is sentiment analysis. It determines the emotional opinion expressed in text. For example, the movie was fantastic. This could be classified as a positive response, and the service was terrible. This could be classified as a negative response. And the next one is chatbots. Natural language processing system allows some chatbots, virtual assistant, AI tutors to understand questions and generate appropriate responses. The last one is text summarization. It produces a shorter version of a longer document while preserving important information. For example, we can summarize a long and large news article and produce a short summary. So how does NLP or natural language processing systems process language? We can think of NLP as a pipeline. The first step is text ingestion. At first, the system ingests text, and then the tokenization means dividing the text into smaller units called tokens. Modern systems can use subword tokens rather than complete words. And then we can pre-process the tokens for better model performance. And finally, the input is fed into the model. So, what is pre-processing? Before feeding text into a traditional NLP model, the text may need pre-processing to clean and normalize it for better model performance. Some common pre-processing techniques are lower casing, stopword removal, stemming, lemmatization, and normalization. As we know, lower casing means converting the letters into lowercase forms. And then stopword removal means removing some words that are frequently used and that do not contribute to a particular task. For example, the cat is on the mat. We can remove the be verb is and the preposition on and the definite article the, because they do not contribute that much to the particular task we are performing. Then comes stemming. Stemming for example, playing, played, plays. These three words can be mapped to play. And lemmatization is somewhat more linguistically informed. The word better can be mapped to its lemma good. And finally, normalization. Normalization means removing unnecessary spaces, handling punctuations, and normalize spelling and formatting. After pre-processing, the text input is fed into the model, and here we can see some NLP models. For example, transformers, deep learning, machine learning, statistical NLP, and rule-based systems. For example, if we give the input, the movie was surprisingly good. A sentiment classification model would produce the output positive. And in a generative model or a generative model, instead of instead of just predicting the level, it might generate an entire response. um, After model execution, the result may require additional processing before delivery to the user. For machine translation, the output may require grammatical or format adjustment, and for speech recognition, the produced output may require punctuation or capitalization to make the output text into a more readable form, make into a more readable form. And for chatbots, the output may require safety filtering or other post processing. And text summarization also, the output requires formatting and grammatical adjustment. What are the key technical challenges in NLP? The first major challenge is language ambiguity. For example, I saw a bat. Does bat mean the animal, or does it mean the sports equipment? The system needs context. So NLP systems need contextual understanding to produce a better result. Another major challenge is context dependency. For example, he went to the bank. So here the word bank could mean a financial institution or a river bank. So again, the system or NLP models may require contextual understanding to produce a better output. And the most difficult challenge is sarcasm. For example, what a wonderful traffic jam. This sentence may sound positive literally, but it is actually negative. And the domain adaptation, a model that perform on newspaper articles may not perform well on medical reports or legal documents with specialized vocabulary. So these are the technical challenges that the NLP systems are facing these days. And future horizons of NLP, looking toward the future. Looking toward the future, the first important update that the NLP systems require is multilingual models. Future NLP systems will increasingly support many languages within a single model, and this is particularly important for languages like Bengali, Hindi, Arabic, and another update or future implementation could be real-time speech to text instead of just text input. Future NLP models could use speech as input and then generate a response. These will include applications like live transcription, voice assistant, meeting transcription, accessibility tools, and real-time translation. Future NLP systems also need to address bias, privacy, misinformation, toxic content, fairness, transparency, and data consent. A language model should not only be accurate; it should also be responsible and also should be ethical. So that's all. Thank you, everyone.